Hey everyone, continuing for general integration techniques, we're looking at the general power rule. So you may recall from the earlier video that we looked at the algebraic power rule, right, of x to the power of n. So we have integrating x to the power of n dx would lead us to, well, increase the power by 1, divide by the new power, and then adding the plus c. How the algebraic power rule is derived? Well, it's from the different derivative, right? d dx of xn is simply bring down the power, reduce the power by 1. Same thing for the general power rule. It also comes from differentiation. So we have the derivative of fx power of n, right? Same thing, bring down the power and then reduce the power by 1 followed by differentiating inside. Because n is a constant, we can actually add it into our integral. And as such, if we are integrating a product, the first form to actually look out for whether is of the form f prime x fx to the power of n. And this will lead us to, same thing, increase the power by 1 and then divide by the new power, adding the arbitrary constant c. So it's actually the same as how we use the algebraic power rule, and it's actually pretty simple. You just need to watch out for the derivative. Why do I say so? That you need to watch out for the derivative. Let's start with an example. We have integrating x times x squared plus 1. So a way to do it is to just expand it and then integrate it term by term. However, for the purpose of sharing the general power rule, let's do it through the general power rule. So with the derivative of x squared, we know it's 2x. Over here, we only have times x. And because 2 is a constant, we can just add it in. That is why you must also be careful of the derivative. So we let this be f. We already found out that this is kind of like f prime. Therefore, going by the general power rule, we will need to increase the power by 1. So 1 becomes 2, then divide by the new power. Because the derivative is 2x and we only have x, we must also times 2. As such, we then have x squared plus 1 whole thing square over 4 plus c. So what is the difference if we were to integrate it term by term? So let's just integrate it term by term, which means that I'm going to integrate x cubed plus x and obtain x to the power of 4 over 4 plus, well, let me just write the 4 properly, x power of 4 over 4 plus x squared over 2 plus c. There's actually no difference. Why? Because if I were to expand the top here, I'll get x power of 4 over 4 plus, well, 2x squared over 4 equals to x squared over 2 plus 1 quarter plus c. 1 quarter and c are constant, so I can just, rewrite this as d or any other letter. And you realize, well, these two answers only differ by the letter c and d. Okay, so this is one of the examples of general power rule involving algebra. Another example, actually, we can actually use logarithm, trigonometry, or even exponential here, although exponential is kind of rare. So let's take a look at logarithm first, right? So we have ln x over x dx. So this, well, one way to do it is a quotient, but you can also look at it as a product of 1 over x times ln x dx. So obviously, this is f prime, this is fx. As such, we get ln x squared over 2 plus c, right? Another example we have is trigonometry, cosine x, sine square x dx. Okay, so, well, cosine is the derivative of sine, and sine is the derivative of cosine. So what should we label as fx? If you were to label cosine x as fx, the derivative in this case will be sine square x, which is actually not the derivative of cosine x. However, if we let fx be sine x, the derivative of sine x is actually cosine x, and we have it here. As such, we have sine cube x as our integral over 3. In this case, we have fx being sine x, right? And it's sine square x. So we have fx power of 2, which is sine x power 2. Then we have cosine x being the derivative, and therefore it's of the form f prime f x squared, and therefore we end up with f whole thing cube. Okay, so this is some simple examples of general power rule. Slightly more difficult ones involve integration by parts and are actually not of the form that are directly integrable. What do I mean? if we have the example x cubed x squared plus 1 power 7, then things are going to be even more difficult, right? Because they're not going to expand power of 7, right? There's a lot of terms and there are a lot of numbers and constants that you need to dedicate to each term. So what can we do? There's no directly integrable form for now, and the only way to do it is the general power rule, right? But even if you use the general power rule, we notice that the derivative of x squared is x. The derivative of x cubed is 3x squared, but 3x squared is of the form of x squared plus 1 power 7, so that's impossible, right? So we turn to integration by parts. So if you let x cubed be the term to integrate, right, you know there's no way out, right? Because the other product term is x squared plus 1 power 7. There's no x squared term for you to integrate with to use the power rule. Whereas if we use the x squared plus 1 as a f, right, as a main function, we have, well, of the form x squared plus 1 power of 7, right? Then we times the x squared. Then we realize you can integrate this one as a form of, well, this is f prime and this is fx. So we integrate by parts to get, firstly, x squared plus 1 power 8 divided by 16, right? Because derivative of x squared is 2x, we are missing the 2, so we times, so we have to divide by 2, and then not forgetting to divide by the new power 8 to give you 16. And then lastly, we add the x squared term. Minus sign, now we differentiate the other term to give us x squared plus 1 power 8 over 8. Because you already differentiate x squared, you give back 2x over 16 is 8. Then what you notice is that, well, now we can integrate again because this is your f power 8 and then this is just f prime. So we can do it, you can apply the general power rule again to give us x squared plus 1 power 9 over 72 times 2, so 144 plus c. So again, increase power by 1 to become 9, then divide by 9, so 8 times 9 equals to 72, and then I have to divide by another 2 because the derivative of x squared is 2x and I'm missing the 2 here. So this will be my derivative. Obviously, you can simplify this as, you know, you factorize out x squared plus 1, x squared plus 1 power 8 over 16 to give you, if I'm not mistaken, 8x squared over 9 minus 1 over 9 plus c. I think this is the correct one. I hope so. I'm not sure. Let's see. I get x squared minus x squared plus 1 over 9 plus c. So, oh, I think I'm correct. Yeah. X squared plus 1 over 8 over 144. So I'll get 8x squared minus 1 plus c. Yep, there was a little hiccup there, but yeah, I'm actually correct at first. But yeah, what did I doubt myself? Anyways, this is a way to use general power rule that is actually not directly integrable. As such, we kind of like want to summarize this video, right? So we have the general power rule, and it's of the form f prime x fx power n, and then the same mantra as integrating x power of n, we increase the power by 1, and then we divide by the new power, and then not forgetting the plus c. So there we have it, the general power rule.